Assalamu alaikum wa rahmatullahi wa barakatuhu, friends. Welcome back to my channel. When we take output from any SMPS, it must be stable. That is called regulated output. While connecting a load or due to any reason, if the voltage level is not stable, that is called unregulated output. Maybe from different conditions. Due to any component failure, due to any malfunction. So let's start. What is the fluctuation? Fluctuation is the variation in the output voltage. Sometime it is in millivolt. For example, 12.03, 04, 12.18. Maybe sometime it is in volts, 11 volt, 13 volt. Sometime it is more, 10 volt to 13 volt, 14 volt. That is fluctuation. Sometimes the power supply starts from 0 volt, 1 volt, and it reaches to maximum level and then it returns back. It makes restart. That is also considered in the sense of fluctuation. What are the basic reasons for this fluctuation? It is a message from one of my viewer.
ये मेरा क्वेश्चन ये था, ये आपको जो मैंने सेंड किया 12 वोल्ट का एडाप्टर है, इसमें वोल्टेज फ्लक्चुएशन की दिक्कत आ रही है। आउटपुट में मैंने शॉर्टकी डायोड, कैपेसिटर सब कुछ रिप्लेस करके चेक किया है, इनपुट में भी सब कुछ चेक कर लिया है, रेक्टिफिकेशन सर्किट ओके है, आउटपुट ओके है। इसकी जो VCC पिन जो है इस चिप की, जो कि सॉफ्ट स्टार्टर करती है, उसके कैपेसिटर को जब मैं चेंज करता हूँ तो थोड़ी देर के लिए वोल्टेज फ्लक्चुएशन बंद हो जाती है, लेकिन कुछ देर बाद में वही प्रॉब्लम क्रिएट हो जाती है। इसकी क्या वजह हो सकती है?
In this question, he asked me that he tested all the components in the output side. All components are good. He replaced the VCC capacitor here. This video is a general video. For any type of SMPS, you can utilize this phenomena. He said, I replaced this capacitor and after some time, it starts fluctuation again. We will see the reasons why it makes fluctuation. There are some symptoms. We will discuss one by one. First of all, I will share the checkpoints, how we can test the power supply, how we can say it have fluctuation or no. Set multimeter to DC and check the DC voltage at the input capacitor. This time I am applying 110 volts. I am applying 115 volts, 115 AC, and the DC voltage, these are 159.7 volts. It's normal, 159.6.7, so it is not a fluctuation. If these voltage are moving from 157 to 160, 155 to 160, or in case we are using 220 volts. If I apply 220 volts, it is 231.5 volt, 232 volt AC. And how much the DC voltage? That is 326 volts, 326.4. Now the last digit, it is moving in millivolts, it is changing in millivolt. But if it change in volts, for example, we can say 324, 326, it is jumping up and down. That means the power supply may have problem. Then there is this capacitor, which is the most important, that is VCC capacitor. We have to monitor it. In a good working condition for UC3842, it is 12.22 volt. It is stable. If it is varying from, we can say 8 volt to 15 volt and it is jumping up, down, or it have a light variation. For example, if it have a little bit variation, we can say 12.1 volt to 12.4 volt, 5 volt, or 11 point some volt. It is varying in millivolts. That will called fluctuation. And if it have a variation from 5-6 volt to 16-17 volt, and then again 5 volt, 16 volt, variation from lower level to upper level, too much long variation, that will called restart. What are that? Let me power it off. And the output voltage, if it have a little bit variation, we can say in millivolt, that will called fluctuation. That fluctuation may be due to many reasons. We will discuss one by one. We have to consider this 384243 IC, UC3842, 43, 45. These ICs have a VCC pin. In initial stage, these take voltage from the DC rail. There is a startup resistor. In initial start, it will charge this capacitor, that is VCC capacitor. When the voltage will reach, in case of 3842 series IC, UC3842, when it will reach at approximately 16 volts in the initial startup, it will start switching. When it will start switching, initially the capacitor was empty. When this resistor will provide charging current, it will control the current for these capacitors. When this capacitor will charge through this path, then its internal comparator will start the switching. It will start the switching, this MOSFET. This MOSFET will start switching. At that time, our this winding, primary winding, will take current and it will provide voltage in the output side. In this time, the charging will continue, but this cannot provide too much current for the operation. For example, this resistor network is charging at 1 microampere, but the IC is taking, we can say, 7 microampere. So when this IC will start switching, we are taking 1 microampere. It is an example for any power supply, for any switching IC. From here, we are providing 1 microampere. This IC, when start switching, it will consume 7 microampere. We need 6 microampere more, but this time IC is switching and the voltage started to produce in the secondary and voltage started to produce in this winding. When it will start switching, it will provide the remaining current to this pin, and same time it will receive a feedback from the output side. If the output voltage are okay, 5 volt, 2 ampere, the load is within the limit and voltage are 5 volt exactly, at that time our this circuit will give a feedback to this optocoupler, and optocoupler give feedback to pin number 2, so that this IC will work smoothly. Now, when there is a load, at that time the voltage level will drop at this point. When the voltage will drop, what will happen? This light will reduce. It will control the feedback pin, and the reference voltage which are being applied to this pin will reduce, because we are applying reference voltage through this transistor to pin number 2, feedback, compensation pin and pin number 2. Now what will happen? The IC will increase its duty cycle. When it will increase its duty cycle to meet the requirement at the output pin, that is 5 volt, it have a limit. When it is increasing, here we have overload condition. We added some load. When this load is applied here, same time the voltage are being decreased due to overload. What will happen? the voltage will increase in this pin as well. At a specific limit, if we have 2 ampere maximum limit, if we put 3 ampere load, it will drop the voltage here. So it will drop the pin 2 of this IC, it will increase the duty cycle. When it will reach its maximum limit, we can provide 2 ampere but we added load 3 ampere. So this IC reached at maximum duty cycle. At that time these voltage will increase. In normal operation it will provide 10 volt to 11 volt, 12 volt. We checked 12 volt here, that's okay. So these voltage should remain between 8.4 to 16 volt, from 9 to 16 volt. If it will remain in 9 to 16 volt, that time this IC will work smoothly. But when it reached its maximum duty cycle, at that time these voltage will increase and this pin will become above 16 volt, 17 volt. So this IC will go in overload condition. At overload condition, this IC will turn off. It will turn off the switching. The IC is active, just only it will turn off the drive. It will consume these voltage, because now the current is not flowing in the primary, so no voltage in secondary, no voltage in this winding. So capacitor will compensate the requirement of this IC. When the voltage level of this IC will decrease less than 9 volt, at that time this IC will start again. In overload condition, this IC will remain silent until the voltage will reach in the safe limit. When it will switch again, it will activate its MOSFET, the voltage will start again in the output section. The load is present. When this load will draw more current again, so it will terminate the operation again. The voltage will drop. That time when it will come in safe limit, it will switch again. So this switching again and again, restart mode, it is caused to drive the fluctuation. The first problem, that the voltage here are not reaching properly due to reaching at maximum duty cycle. Second thing, overload. Or might be we have not applied any load. Maybe this capacitor is short circuit from inside. The IC is switching. It tries to switch and it cannot find the feedback. It will switch, it cannot find the feedback, it will switch again, it will go in overload condition. Why overload? Because this winding is not providing voltage at the output pin to activate the feedback circuit. When it is not providing the voltage because it is making an internal short circuit, internal loop, but this VCC winding, auxiliary winding, will provide more voltage at this pin, so this IC will go in overload protection. It is our first condition. Then the second condition, if this winding is not set properly, maybe at, we can say, 50% duty cycle, it will provide 16 volt, so this power supply will not take full load. This is second condition. So we have one condition here, that is feedback network. The second condition, this startup resistor and this winding. These things are involved with fluctuation. The third thing that is involved here, that is this capacitor. If this capacitor will provide ripples, it have internal open. If it is short circuit, it will damage the fuse and everything. And if it is open, it will not store the charge properly. When we will try to drive the primary, its voltage level will decrease. When voltage level will decrease, so IC will terminate the operation. These are the basic elements for any fluctuation. The first, we need a startup voltage. If the startup circuit is working good, then we need voltage from this auxiliary winding. It will start from this circuit And then if this value is at this point, if it is 9 to, for working voltage, if it is 9 to 11 volt, 12 volt, it will work good. And its maximum limit, that is 16 volt. At 16 volt, it will go in overload protection. If the voltage will decrease less than 9 volt, 8 volt, at that time it will go into under voltage lockout condition. When it started switching, we cannot find something in the output. It is switching the MOSFET, but the auxiliary voltage are missing due to this rectifier, due to shortage in the capacitor, leakage in the capacitor, the voltage level are dropped, or due to this protection diode. If we have anything wrong, it will not produce a proper VCC voltage, because the VCC voltage are the basic element to operate any IC. If we have something wrong here, it will sense the fluctuation at pin number 7 of this IC. If we have not a proper feedback circuit, if the current transfer rate is not good, feedback circuit is not working good, at that time it will make fluctuation, because it cannot adjust its duty cycle at required level. So these are the checkpoints. We can check pin number 7 in case of UC3842, output circuits, main capacitor. To detect the problem, optocoupler, TL431 or any source of feedback or voltage sensing, sometime it is not using TL431 or any adjustable reference, might be there is some Zener regulator or something which can provide voltage to this optocoupler. Then we will see another example. Sometime we are using IC with built-in MOSFET like TNY278PN. If we see its data sheet, in this situation it is not using some startup resistor, it uses its internal startup circuit. So it is at bypass pin. So here is bypass capacitor. In this situation, we will take a feedback voltage, VCC voltage, from transformer, rectifier and this resistor. When we work on any power supply, we must check the data sheet for the SMPS controller IC. We have to check the voltage, bypass voltage. If the voltage, the normal voltage should be at 5.85 volts, that is nominal. If 5.6, that is okay. 6.15, that is the maximum limit. If at normal switching the voltage will go beyond this limit, at that time this IC will turn off the operation. So we have to take care for this voltage. How we can set it? We can set by this resistance. We can check this capacitor, diode. If we have something wrong here in these three components, or something wrong in the secondary side, in the feedback network, that time we will find fluctuation. The similar here, if the main capacitor is not charging properly and it is providing some ripples in this section, at that time the ringing factor will arrive in the primary, so it can cause also fluctuation. This capacitor to second capacitor, auxiliary voltage section and the output section. If any diode, anything short circuit here in the secondary, it will reflect to the fluctuation. Friends, I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.